Question number 8 is the first question where we have limiting reagents and stoichiometry. So it represents a new level of challenge in solving the problem. The first step in solving this type of problem is to balance the equation. We have sulfur tetrafluoride, diiodine pentaoxide, iodine pentafluoride, and sulfur dioxide. And when I balanced it, the first thing I looked at was the F5. So I didn't have these numbers here when I got the equation. How did I balance it? The first thing I looked at was the F5 and the F4. I knew that it had to be 4 for the F, the IF5, and 5 for the SF4. The only other places where you have, it's the only places where you have fluorine. There was no fluorine anywhere else in the equation. So I knew that those were the first two that had to be balanced. Then I looked at the sulfur. It said 5SF4. So 5S's have to be here. So I put a 5 next to the SO2. That gives me 10 oxygens. The 10 oxygens were balanced by putting a 2 next to the I2O5. The iodides take care of themselves. 2 times I2 is 4 I's, and then you have 4 I's here. So everything balances now. And once we have the proper stoichiometry, we can begin solving the equation. The first step is to take the amounts that we're given. We're given 4.687 grams of SF4 and 6.281 grams of I2O5. So we divide by the molar mass of this molecule to find that it has that many moles of SF4. And we divide this one by its molar mass. See, 2 times iodine's molar mass and 5 times oxygen's molar mass, to find out the molar mass of I2O5. And then what we do is we pick one. Pick one of these values. Doesn't matter which one you pick. I solved it 2 different ways. This way I solved starting from here, and this one I solved starting from here. So let's start from here and see what happens. So I took 4.33 times 10 to the minus 2 moles of SF4, and I put in the conversion factor for the stoichiometry. What is the stoichiometry? It's 2 moles of I2O5 for every 5 moles of SF4. How did I know to put it 2 over 5 and not 5 over 2? I want to eliminate SF4. SF4 is in the numerator. So if I want to eliminate something that's in the numerator, I have to put the same thing in the denominator. So I knew that the 5 moles SF4 had to appear in the bottom of the conversion factor. That tells me that this reaction requires, never fails, this chemical reaction requires 1.73 times 10 to the minus 2 moles of I2O5. So that's what you need for this amount of SF4. But we actually have 1.88. So we actually have more of this stuff than we need for the chemical reaction to be completed. Therefore, we can say that this is in excess, and SF4 is the limiting reagent. So we found that out. Starting from here. We can also find it out starting from there. If we start out from here now, though, we're not going to use 2 over 5, we're going to use 5 over 2, because now we're trying to eliminate moles of I2O5. So we're going to put moles of I2O5 on the bottom. The conversion factor is 5 over 2. That means we need 4.704 moles of SF4. But we actually have 4.33, so we have less than we need. So that tells us automatically SF4 is limiting. So we solved the same problem 2 different ways. The question they asked was which one is limiting, and we found out that SF4 is limiting.